everybody, in this video we're going to look at local behavior of a rational function. Notice that the graph has two pieces. I first want to start by looking at where the function looks like it splits in two. And for this function, it looks like it splits at the line x equals -4, which would be a vertical asymptote. From here, I want you to see there's a right side and a left side to the graph. We call the right side of the graph -4 from the positive side. We call the left side of the graph -4 from the negative side. Let's start by looking at what happens to the function as we approach -4 from these two sides. We'll start by looking at the function as x approaches -4 from the positive side. To help us visualize that, I'm putting a point on the function, and I'm going to move that point closer and closer to this line where x is equal to -4. Notice that the y value gets smaller and smaller. It's in fact going down to -infinity. So we would write, as x goes to -4 from the positive side, f of x goes to -infinity. Let's repeat that on the left side. Again, I'll put a dot on the graph, and I'm going to drag that dot closer and closer to -4. This time we're looking at what happens as x goes to -4 from the negative side. As I move the dot, you can see the dot is going up, so my value is increasing. We would say as x goes to -4 from the negative side, f of x goes to positive infinity. The second type of behavior we want to look at is the end behavior. We want to know what happens when x goes to infinity or when x goes to -infinity. And again, we think of there being a line. This time it looks like we have a horizontal asymptote at y equals 2. So if we go back to putting a dot on the right side of the graph, as x increases and goes to infinity, we can see that our f of x is going toward this value of 2 that we see in our asymptote. Repeating that on the left, we can see that as x goes toward -infinity, our value comes closer and closer to this line y equals 2, which says as x goes to -infinity, f of x goes to 2.